Welcome to the experiment on the reduction of camphor to isoborneol. In this reaction, we are going to complete this reduction reaction. We are going to look at the stereochemistry of our final alcohol, and we're going to use NMR to distinguish between the two isomers of the alcohol product. This is a reduction reaction as the number of bonds that our carbon has to the oxygen reduces. The mechanism for this reaction is we have a hydride ion from the reducing agent sodium borohydride that acts as a nucleophile and attacks the carbonyl carbon, kicking those electrons up onto the oxygen. In a second step, we simply protonate our alkoxide ion to create our alcohol. Overall, a nucleophilic attack followed by a proton transfer. In this reduction reaction, we have decided to use sodium borohydride. It is much easier to use than lithium aluminum hydride and definitely gets the job done. In this step, the hydride can approach the camphor molecule from both the top or the bottom, and it turns out it's easier from the bottom side. Those two methyl groups off the top sterically hinder the exo approach. Although we do get both products, part of this lab experiment is for you to determine how much of each isomer we do obtain. For this experiment, I took 0.1 grams of camphor out of the bottle and put it into a 10 milliliter vial with a magnetic stir bar. I then added 0.5 milliliters of methanol to my camphor in the vial using a pipette. Once all of the camphor is dissolved, cautiously and intermittently add 0.1 grams of sodium borohydride to the solution. Make sure you don't leave the cap off the bottle of sodium borohydride. When the borohydride is added, boil the contents of the vial on a warm hot plate at the lowest setting for 2 minutes. This is me cautiously and intermittently adding my sodium borohydride. Now I'll let the reaction cool for a few minutes and then carefully add 3.5 milliliters of ice water. And then using a Hirsch funnel. Wait, stop. What is really wrong with this picture? Be sure to discuss this in your lab report, including its effect on percent yield. Okay, resume the filtration. And then using a Hirsch funnel, I will vacuum filter this solid, allowing it to dry for a few minutes. Adding additional ice water to try to get more product out. Maybe even using a spatula to try to scrape some to get it all. And then finally using a pipette to try to get the rest of that product out of that vial. We want to try to get it all. Each time we add more cold water to the vial, we're also rinsing our product with that cold water, so that is good. Continue to filter, and if I freeze frame here again, you can see I really should have paid more attention. Filter, and then leave it on the vacuum for a couple minutes to try to get the product to dry as much as possible. Turn the vacuum off, and then pull your funnel off. Good. And then try to quantitatively transfer your product into a vial. You have to be patient and try to get every little piece of the product in this step as well. Once you've transferred your solid to a clean 10 milliliter vial, cap it and get ready for the diethyl ether. At this point, we will add 4.5 milliliters of diethyl ether using a pipette to dissolve our product. Now we will add a few spatula tips of anhydrous magnesium sulfate to dry our solution. Once I add the mag sulfate, I typically let it sit for a few minutes just to let it kind of capture all of that moisture. Then place a piece of cotton into the bottom of a glass pipette. It'll be kind of like a funnel. Push it down with another glass pipette. So that's kind of going to block the mag sulfate and allow our product to go through. Pre-weigh your new vial, and then we will transfer our product, minus the mag sulfate that'll get held up by that cotton, through the glass pipette into our new pre-weighed vial. So now try to quantitatively transfer the rest of that product through the glass pipette filter into our new pre-weighed vial. For the record, there were 3 steps where it was challenging to transfer. The first out of the reaction vial, the second out of the funnel, and now here cannot quite get it all out of the vial. Once I get it all transferred to the vial, I allow the solvent to evaporate and capture the mass of my final product. And now, safety with Jane.
The reactants in products are all highly volatile and must be stored in tightly closed containers. Diethyl ether is extremely flammable. Methanol is toxic to the optic nerve. Sodium borohydride is a flammable solid and is especially dangerous when wet. Any leftover methanol or ether solution should be placed in the organic waste container. Easy peasy.
There you have it, the reaction of the reduction of camphor into isoborneol. The proton NMR of this experiment in the 3 to 5 range is going to be very important in determining which isomer you have. That was a little hint. Okay, good luck!